Hello, and welcome to Converting a Game Engine to TypeScript with me, Josh Goldberg. A little bit about me first. Hi, I'm a front-end developer at Codecademy. I work on our shared front-end tooling on our web platform team, things like React and TypeScript and Webpack. I really like open source software. On the side, I like to work with or contribute to tools such as ESLint and TypeScript for fun. You can find everything that's in this talk on my website at joshuakgoldberg.com, and I also tweeted a link on Twitter at joshuakgoldberg. I have spoken at TSConf before. In 2019, it was a pure theory talk about implementing binary arithmetic in the type system, a mouthful. The next year was also another fun theory talk on implementing a rudimentary game engine, again purely in the type system. For this year, I'm sticking with the game engine, but going a little more practical. We're talking about converting an existing JavaScript game engine to TypeScript. As that agenda, I will start off with talking about the JavaScript years, how that project came to be and what it was like before TypeScript. I will bring up why TypeScript is useful, both specifically for a game engine project and in general why it's a fantastic tool. I'll talk a little bit about how to convert to TypeScript, some of the major strategies you might want to choose between. And I'll end with some fun errata, little things, cute pieces of code that worked well in JavaScript but work better with TypeScript. And all that being said, let's begin. Let's talk about the JavaScript years, life before TypeScript. The project in question is an old game called Full Screen Mario that I made back in college. It was an original Super Mario Bros. Remake. It consisted of the original 32 levels, a random map generator, a level editor. It was open source, online. It was pretty cool, went a little viral, and then Nintendo shut it down with a DMCA copyright complaint. A little less fun at that point. It was my first big JavaScript project. It was built in my spare time without a real solid development focus over a year, meaning I didn't really know what I was doing. I didn't think too hard about it. I decided to write my own integrated game engine rather than use a pre-built one such as Phaser.js the way a normal person would. I realized late in development that although it was very educational writing my own game engine, it was also a terrible, terrible idea, and I needed to make some real important adjustments, such as not using DOM elements as the game and actually using the Canvas APIs. And perhaps most importantly, I didn't know how to structure a project at the time. I didn't understand bundlers like Browserify that were popular then, and this was before modern ES modules or ECMAScript modules. So in a nutshell, it was the worst code I've ever written. Kind of proud of that. It was absolutely terrible, incomprehensible garbage, but it worked. It actually worked, shockingly and horrifyingly. But there were some truths that came out of the project for me. One was that even though the project structure might not be good, or it might not be followed particularly well, if a project is large and generally works, there's some structure at play, some logical cohesion to the way it manipulates data and state. In the case of Full Screen Mario, I ended up splitting into two major phases of logic, gameplay and graphics. And these would be run on the upkeep or tick, which happens every game frame, and at 16 FPS or frames per second, that's 16 of these per second. The gameplay tick section was itself split up into three little units: quadrants, maintenance, and events. Quadrants was reacting to the player moving around in the map, thus spawning new actors, or at the time they were called things, in the game screen. And then also reacting to collisions. If, say, the player runs into a piranha, or if a Koopa falls off a cliff, what happens? In the second gameplay phase, we had maintenance, pruning any objects that had fallen too far out of the view box, and regular movements, such as enemies jumping, the player walking, and so on. Lastly, we had one-off events, such as single jumps or fires of lava from an enemy, and cycles, such as characters switching between the normal and the alternate version of a walking sprite. Once all these gameplay events were processed, we would draw them onto the screen. Drawing onto the screen was 2 phases. First, we would refill the screen background, maybe blue for the overworld, or if you had a mod enabled, some kind of nice gradient colors. And then we'd draw the sprites in order of their groups. Scenery would be first drawn, therefore on top of their background but behind everything else. Then solids, and then characters on top of those solids. Easy peasy. Now, eventually I split this all out into its own game engine because I wanted to make more of these things. I ended up really not making too many, but it was still a fun exercise. The game engine is called 8-bitter. It's a play on words of it being 8-bit and me being bitter about that DMCA notice still. On top of 8-bitter is the implementers, say full-screen Mario or later full-screen Pokemon. And on top of that is a little module component called user wrapper that binds the game to the DOM by adding the game canvas to the browser and hooking up event inputs such as key down strokes. Now, 8-bitter is the real fun part of this. This is where the game engine is defined. And 8-bitter has quite a few components that I'll skim over now. To start, there's map spawning, which is all the stuff that stores maps and then spawns them onto the screen. You don't have to memorize all these, don't worry. Next to map spawning is collisions. Now that this stuff is on the screen, how do we know which groups of them are touching each other or getting killed and so on? In addition, we have one-off events, such as the cycles, firing, and so on. We have graphics, storing a library of sprites, rendering the correct sprite per actor in the game, and then rendering those actor sprites onto the screen. We have interactions, things like user inputs, gamepads, touchscreen controls. And then random miscellaneous stuff I couldn't find a better zone for, like random number generation or audio playing. For an even better time, we can visualize all the little dependencies between projects. To recap, just because there's a structure for the project doesn't mean it's good or comprehensible, but this project does have a structure. And projects with structures, whether they're good or bad, is a great segue into why TypeScript. And I understand that at this point in the conference, this being the last talk in the conference, you've probably been talked to quite a lot about TypeScript, perhaps at a cultish level. And that's okay. Either you are already convinced about TypeScript, in which case the remainder of this presentation is very good fodder for you convincing other people of TypeScript, or you're not yet, and I feel obligated to, again, try to convince you that TypeScript is great. It's gotten me a lot of personal benefit, it makes my game engine a lot better, and I hope it can give you some joy as well. But in a nutshell, TypeScript helps formalize and enforce the existing structures in your project architecture. It lets your project, the way it's supposed to be, get enforced and documented well in your code so that you mess up less and write good structures more. This whole project architecture may be convoluted, but that's how things are in real life. This is how code works. It gets messy, and you end up really wanting tools that help you wrangle it and understand the messiness. This is real life. Let's look at an example. This is a single line of code that roughly exists in a game that implements a game engine usage. How do you know whether this is right? Is events.push the correct API? Does this function need to return something else? Are these the right names? Who knows? In just regular or vanilla plain JavaScript, there's no good way of knowing until you actually run the code whether this is the correct thing. But with TypeScript enabled, you get interfaces and type declarations and type annotations that tell you what these APIs are supposed to look like and how to use them. With TypeScript enabled, we can get a little squiggly here saying, no, that's not the right thing. You don't have access to something called events. You actually want to add event, a different API. Correct your code. Thanks, TypeScript. On top of that, TypeScript doesn't just tell you things are wrong. It tells you things are wrong in real time, which is really, really nice because otherwise you'd have to, say, bundle your code, run it in an environment such as a browser, and then get some repro case set up to get to the exact spot to run something, which can be a real pain in the butt, especially if you're working on visuals or real-time projects like a game engine. I'll give you an example of one thing that was really nice with TypeScript. I had a mod called QCount in Full Screen Mario, where if you pressed Q on the keyboard enough, things would start spawning on the screen at random, little enemies, and if you pressed it a bunch more times, you'd have a whole lot of enemies. And turns out the Bowser movement function had a bug that only happened if there were multiple Bowsers on the screen at the end of a level where the original Bowser in that level was one of the fake ones. Fun fact, that's a thing. And let me tell you, it took like 15 seconds to reproduce this every time I had to debug the issue. So I was very pleased that TypeScript started giving me feedback about me using the wrong APIs as I typed them. I missed that mod. That was a good mod. Lastly, TypeScript provides a rich, clear documentation standard. Existing projects in JavaScript, such as JSDoc, don't really get to the exact precision level that TypeScript can offer in letting you explain how your code is supposed to be used. Furthermore, JSDoc is not a binding standard. It's very possible, perhaps even easy at times, to mess up JSDoc or to update code and not update your comments. But with TypeScript, you get something like this, where you can precisely define all the things that are allowed to be used. A time handler object or class instance has these two APIs that return this thing, and this thing has a cancel method on it. Beautiful, precise, usable, and enforceable. Thanks, TypeScript. So now that you're totally convinced, my 3 little points here have completely changed your worldview. Welcome to the cult, or you are already convinced, in which case, nice of you to stick along. You probably want to know how to take an existing JavaScript project and turn it to TypeScript, which I will summarize for you. To start, there are a couple strategies you can choose between or flex around in. You might want to convert all your stuff at once, which is particularly nice if you have a smaller project and/or a project that doesn't get too much developer activity day to day, which I like to think of as the YOLO method. Just go ahead and do it. YOLO. Yay. But if your method of just YOLOing it and going all at once might be a little in conflict with other developers, you might try doing one area at a time. For an 8-bitter, I went with one area at a time because I wasn't particularly familiar with TypeScript when I was starting out, and I wanted to get a little more experience as I went along. So I went with all the little leaf nodes in the project dependency tree, meaning the projects that didn't themselves have dependencies on other projects. I converted them to TypeScript first, and in doing so I learned about the language and what worked or didn't work in setting things up with TypeScript. Once that was done, I was able to use learnings from that conversion in the other modules, in the other projects, so that by the time I got to the end of converting to TypeScript, I had a beautifully typed flowing state diagram in TypeScript and just a really nice project to work with. Thanks, TypeScript. The steps for each project were relatively straightforward. I would create a tsconfig.json file, which is the file that specifies your compiler options and which files to run them on. I would add TypeScript as a dev dependency, along with whatever build processes were necessary. I would rename all the JS files to TS. Then I would start the TypeScript compiler in watch mode, tsc-w, and fix errors until the watch mode reported none. As an example of a really nice build toolchain, I bring to you Babel, which has a single preset you can install as a dependency and add to your config that allows Babel to read TypeScript files just like any other. Very nice integration there. Another strategy question as you're fixing errors you might want to ask yourself is, how strict do you want to be from the offset? Do you want to go into just the ship it mode of immediately getting as little type strictness as possible while still on TypeScript? The benefit of which is that you get onto TypeScript sooner. The drawback for which is you don't have particularly strict typing, not as much gets enforced. Or you can go with stricter compiler options, 2 of which I'm particularly fond of. Strict null checks says that you can't pass null or undefined in places that don't allow the type of something to be null or undefined, which might be surprising to you is not on by default and is often referred to in industry as the $1 billion mistake. Would recommend keeping it on when possible. In addition, there's no implicit any, which enforces that if TypeScript can't infer the type of something from its usage or initial value, then you should provide a type for it, which means that you have a lot more type information about your code, but you have to fill out a lot more of that information. So 2 flags right there that are really useful, but you might not want to start with. Personally, I tend to, in my experience at least, find more success enabling strict null checks first, but it really is up to each project's needs. A couple more tips. To start, would not recommend fixing bugs in a large TypeScript conversion PR. If your PR already changes a whole bunch of information that doesn't affect runtime, it can be very difficult to review code that also changes runtime behavior. I have predominantly caused within the spectrum of my TypeScript conversion bugs within these pull requests when I get over anxious or over eager and want to fix the runtime. It's really hard to review. So my recommendation is resist the urge to fix runtime bugs in your TypeScript conversion PRs, mark them as a to-do and save them for later. In my Converter React app to TypeScript workshop, I give a couple of examples of how to do that. Second pro tip, resist the urge to get everything perfectly right no matter what. A lot of developers feel a little icky using something like an anycast, which tells TypeScript, shut up, I don't care about the errors, just let me do whatever I want on this thing, give or take. But sometimes it's not worth it to get perfect on a particular area of code. If your code base is wacky and difficult to represent in a type system, maybe just as any instead of banging your face into the keyboard until it works. So use this little escape hatch when you really need, and maybe file to-dos to clean it up later. Lastly, let's talk about some fun little stuff that I found converting to TypeScript. But I want to note, TypeScript clarifies JavaScript patterns, it enhances the patterns, it makes them easier to understand and enforce, but it doesn't add its own architectural opinions. TypeScript doesn't say use classes instead of functions or use functions instead of classes. TypeScript adds clarity to JavaScript, not its own opinions. I want to make that very clear as I go through things. This is all stuff that you can do in JavaScript. It's just made better and nicer with TypeScript. To start, let's talk about random map generation. The original full-screen Mario random map generator code was a whole bunch of imperative functions strung together. They took in a little bit of input and then pushed to some arrays somewhere. This allowed them to be really flexible, really easy to tinker with, but kind of unstructured, and really easy to mess up also. I ended up accidentally writing a whole lot of helpers that were pretty much duplicate code that I should have cleaned up. Later on, the game engine ended up using a new format for maps. It stored maps in JSON, or at runtime POJOs, plain old JavaScript objects. A little less flexible, but a lot easier to understand, I think a lot easier to read, and a lot easier to make tweaks in if you just need a quick little change to a number. Also, as a benefit, I think this is pretty cool. I think it's cool that you can represent an original Mario map in JSON, or you can represent the settings for a random map generator in JSON, something that can be safely and securely shared between users. I think that's fun. And TypeScript made these interfaces a lot nicer when I started literally using TypeScript interfaces to describe them. If you wanted to, say, have an area with random contents that adhere to the particular direction and probabilities, TypeScript would let you define an interface explaining the expected properties, and then as you typed usages of that interface would let you know these are the expected keys here and this is where you're messing up. Very freaking useful. Found a lot of bugs when I switched over to TypeScript. Another cool thing is that TypeScript lets you do type-safe curried parameters or curried arguments. TypeScript can recognize that a function has a particular set of parameters that have particular declared types, and if you call that function, TypeScript will reinforce what you're supposed to call it with is actually what you're calling it with. In this example, TypeScript can also infer that this add-event API is supposed to pass the right arguments to the parameter it receives. One way to do this is with a relatively newer feature in the TypeScript type system called conditional types. Ta-da! You don't see the explicit implementation here, but there's a built-in type called parameters that allows us to infer from the generic pass to add event what the parameters are supposed to be. I think it's really cool. And the end result here is that TypeScript can not just inform us what is supposed to be passed to an API, it can also enforce that the right arguments are being passed along with the function. Another cool topic here is that classes are actually really useful sometimes in game engines. If you have a lot of objects on the screen, and many of them have very similar properties, say you have 30 bricks and all the bricks have the same collision functions. To save memory, you can create a class for, say, your bricks, a brick class, and then store the common methods or common properties on the class prototype, allowing each brick instance to only store the unique things on itself, say its X and Y position. This allows you to not just make understandable code with a strong class hierarchy, but also save a little bit of memory. Now, ObjectMakr is the name of the component I used to auto-generate those classes. You don't even realize they're classes until you look into the implementation. All you see is that ObjectMakr receives an inheritance diagram and a set of properties. Then when given a name of one of those classes that you want, it creates an object with those properties on it. In this case, block is the only implementation or only subclass or derived class of solid. Blocks have a photo string and solids have a size number. By the way, small pro tip not related to TypeScript, lazy initialize in performance critical things. The original version of ObjectMakr created all the classes that could possibly exist in the universe on startup, all the defined properties and inheritance mappings, which when I measured in full screen Pokemon was almost half a second. If you switch your classes to lazy initialize, meaning if they don't get created until they're needed, you can do a lot less work up front. In the case of full screen Pokemon, it brought down the actor initialization to about 10 milliseconds, therefore cutting the initialization time in half. I liked that a lot. Anyway, back to TypeScript. Typing these things was actually a little bit of a challenge. I at first had to manually write out all the interfaces by hand, which was not super duper fun. And then also every time make was called, I had to provide a generic explaining which interface it was making. In this first line of code, that's called .make block creates a block for the generic. So a little bit of rewriting there. In a V2 of this, I used a really nifty TypeScript feature called function overloading, which allows you to define different inputs and outputs for the same function in limited ways. Here we say that if the type is known to be the block string, we return the block interface. If it's solid, return a solid. Which meant we were still putting a little bit of extra effort into the implementation of writing out the interfaces, but we were slightly more intelligent when calling make. And I actually want to give you, the audience, a challenge here. You can get complete inference for TypeScript types working automatically in the type system that we set up using a generic on the ObjectMakr class. Once it receives the inheritance and properties, it then knows how to create the right objects in the type system. It's very nifty, a lot of cool features at play. I've got a GitHub issue linked in the slides here that shows you how to do it. Anyway, to recap, JavaScript is cool. I made a game engine in it. TypeScript is really useful for improving your JavaScript structures, at least helping clarify them. There are a few strategies you can take when converting to TypeScript, and a lot of fun little things you can do in JavaScript that are made easier with TypeScript. Some resources: shout out to Speaker Order for revamping the TypeScript docs and websites. 8bitter is also available on GitHub if you want to play around. Would not recommend using it in prod. It is not ready for that. And then if you want to compare architectures now versus earlier, I wrote an article in 2013 on Full Screen Mario. Thank you very much. Shout out finally to the conference organizers for throwing a great conference. You rock. And you can find me at Joshua K. Goldberg at joshuakgoldberg.com. Cheers.